So, you're all here for how much RAM am I really using, I hope? Everybody's in the right session? Nobody needs to go anywhere else? It's your last chance. Bail now or bail never. Okay. So, White Star Software, we are the oldest independent consulting organization focused solely on Progress OpenEdge in the world. Our breadth of experience is unmatched. We've been doing this for a long time. We do everything from very small, tiny, chaotic customers to large, hyper-organized organizations that have global reach. We work with all sorts of different application environments and databases. We've seen it all, one way or another. And of course, we're frequent guest speakers at PUGs and fun events like that. So, you've probably seen us before somewhere. I'm Tom Bascom. I've been a Progress user since 1987. I don't know if all of you were born then, but I have indeed been working with Progress for that long. And I'm the author of ProTop, which I talked about in the previous session, and I'm not going to talk about at all in this session. So that was the end of that. So, the agenda here. This is all about how much RAM am I really using? This is a question that comes up often, but some of the sub-parts of this question are, who cares? Does anybody really care how much RAM you're using? RAM's cheap. You can get plenty of it. Why is it so difficult to answer this question? And what is the actual answer? So that's what we're going to cover here. So who cares? Well, your sysadmins care. Your developers might care, although it's hard to believe sometimes that developers care how much RAM they're using because they're really good at using lots of it. DBAs care very much. So if you're a database administrator, you probably have an intense interest in how much RAM is being used. Of course, your company's bean counters care because they have to pay for it, so they like to know how much you're using. And it goes both ways. You can be using too much, so they have to pay for too much, or they may have already paid for it and you're not using it, and that's just as bad as using too much. And of course, anybody who has seen the infamous Linux out-of-memory killer message. So if you've ever been running Linux and you were going along having a happy day and then all of a sudden your database crashed and everything came tumbling down because the out-of-memory killer killed you, you're very interested in this topic. So, should that killer appear, then probably the first thing you're going to do is go into some of the system utilities and say, well, how much RAM am I using? So you might fire up top, for instance, and you'll get a whole bunch of stuff on your screen that looks kind of like this, and you'll say, huh, what? What does any of that mean? Or you'll look at it and you'll say, wow, that's great. I got plenty of memory on this box. Whoops. This little clicker is pretty sensitive. But then what happens is somebody adds up the column of virtual memory use or one of the other columns and says, oh my God, I'm using a terabyte of RAM. And then they panic. Or I'm using all my swap. Or you'll find some number on one of these screens and you'll think that you're using an amazing amount of memory. And so that phone call happens. And we get these calls from people or an email from people fairly routinely where somebody is convinced that their Progress database is using more memory than has ever been produced in Taiwan in the last 10 years. So we'll have to explain, well, where's the memory going? What's happening with this memory? Why does it say that? And then you go through a long process with people of trying to help them understand what it was that happened in the first place. Okay. I got to put that down because this is just going to keep happening. So why is it so difficult to answer that question? Well, the reason it's difficult is because there's really two questions there and some unstated assumptions about what people mean when they say, how much memory am I using? And the first question is, how much RAM? So what you want to know, what people want to know, is how much of the physical memory, the little chips that you put in your computer, are you using? Not the virtual memory, but the actual physical RAM that you paid for. And you want to know that so that you can efficiently use what you already have. So if you bought a terabyte of RAM, you want to use it, right? You don't want it to just be sitting there being wasted. And correctly forecast what you need. So if you have a growth kind of a situation going on, maybe your business is growing year over year, or maybe you're looking at migrating to a new server, you're going to want to properly size that server so that you can actually support the business correctly and not spend more money than you have to. If you don't need a terabyte of RAM, why in the world would you buy a terabyte? Well, because it's practically free, that's one reason, but you know, not all of us have bottomless budgets. The other half of the question is, how much am I really using? So there's the RAM and there's the how much you're using. And what people mean by that is, what is the impact of this one particular process? So if I start up a new app server session or I start up a new Progress client, how much additional memory impact does that have? That's the hard thing for people to figure out. Or another way to put that is, if a particular process that's already running gets killed, how much memory goes back to the operating system? Now, when the out-of-memory killer kills a process, you usually get it all back because the database crashes and boom. So that's something you want to avoid. But we don't care about shared pages. So the global shared memory pool is not what we're after here. That's shared across all the processes. We don't, that is not an individual incremental amount of memory that's being used by this new process that we've started or the one that we want to kill. And we don't care about pages that have been allocated but which aren't used. So that would be a page where, you know, you said you needed a gigabyte of RAM, but so far you're only using 16 meg. We don't care about the rest of that. You might use it, but you're not yet. And why is it so difficult? Well, it's so difficult because the per process metrics that are being reported down here are all virtual. So you're getting the virtual size of the process, which also includes all of the shared portions of the process. So this is all the memory that your process could address, but it's not necessarily owned strictly by that process. This is stuff that is hypothetically in its address space. None of these metrics report real memory. So what's the difference between virtual memory and RAM? Virtual memory is how much you might use. So on a 64-bit operating system, that's a lot of memory. You could use an enormous amount of memory, but you're never really going to. It includes everything like the shared memory in the -B buffers. It includes shared code. So all the programs that run on the system have shared DLLs, they have shared segments. If something gets read off of disk twice, then multiple people are going to be able to use that because the operating system is very smart about recognizing that you're not the only person who read that. And then if you write something, there's a copy on write feature, so as soon as you do the write, you get a split version, but up until then, you've only got one copy of it. And of course, your file system buffers, so all of your I/O is involved in that too. That I/O information is part of the memory that's being used on the system. And what people really want to know is, what is the unique additional memory usage of this one process? That's what you're trying to get to the bottom of. So then you go out and you spend a day or two or a week searching around with Google. You're on Stack Overflow, you're reading this article, the other article, and they're all talking about virtual memory, and they give you nothing useful. They give you lots of metrics that, well, if you see this metric going this way, that means you have pressure on memory, but it never really answers the question of how much. So what's the answer? Well, wise man once said, you should never say anything more specific than, it depends. And that's true, it does depend. But one way you can figure it out, this is kind of the classic way in the Progress world, is to take all of your Progress startup parameters, read the documentation, find out what the values are, find out what's in kilobytes, what's in bytes, what's in megabytes, and put together a spreadsheet and add them all up. And so if you look at some of the obvious ones, you take the default values, then you would see that your incremental cost of starting up a Progress batch session would be about 4.5 megabytes. That's kind of interesting. But there's a lot of other parameters. Those are just some of the fairly obvious ones. There are 20 or 30 or so that you might have to add up. And that's kind of a pain in the neck. Not every use of memory is a client parameter. There are a lot of things that happen in the database server with the helper processes, the AIWs, the APWs, the BIW, the app server processes, ProAdmin server. There's a lot of Java stuff floating around. The OO4GL garbage collector is infamous for using more memory than you might think. Or maybe I should say, failing to collect as much as you might hope. New parameters can appear. So you get a new release of progress. There's a new client parameter. If you didn't carefully read the release notes, you might not know about that. Progress might change the default values. So when you go from one version to another, default values of some of these parameters sometimes change. A famous one was the temporary block size for temp tables. So temp B size changed a couple of times going from version 9 to version 10, which had quite an impact on people's memory utilization without them realizing that that was happening. Not every process is going to use the same parameter values. So some processes may have one PF file, another set of processes may have a different PF file, so you have different values that you have to account for. And sometimes the documentation is wrong. I know, that's hard to imagine, but it does happen. Nonetheless, it's a really good idea to take some time to sit down and go through your parameter settings and see what is it you expect. What is it you think is happening? It's just a generally good thing to go through that process to figure out how much memory do I expect that I'm using, because you're going to compare that to what you find out you really are using. You might be surprised. So going through all that is kind of a pain in the neck. The other thing is not all that memory is necessarily being used. Those are parameters, but a lot of the parameters are setting a maximum. Some of them are setting an initial value. Some of them are setting how much you increment by. And the usage of memory is not always covered by startup parameters. There are things that don't show up as a parameter. So you can have memory leaks from allocating new objects. So you create dynamic buffers and forget to clean them up. Well, there's not really a parameter for that. So that's another area where you can have some issues. And some of these can be very, very dramatically exceeded at runtime. If you've ever looked at your log file and seen messages about -L being incremented because you exceeded the default value, or mmax being incremented, you can have some very rapid growth in some of these memory using parameters. So how about if we look at it from the operating system perspective? So we kind of looked at it from the progress side. Let's go back to the operating system and see what the operating system has to say. I know you're all surprised I have Windows up here. That's not like me, but there are some tools that you can use in Windows. By default, you have Task Manager and Resource Monitor. Every Windows system has these, and you can get some information about memory from them. Not necessarily what you're going to want, though. So the sysinternals tools, which is the next three here, have much more detail. And you can get these tools from Microsoft. You can download them, or you can get them in the Microsoft Store now. So they're pretty easy to get, and pretty much everybody should have these tools. If you're running Windows and you want to know what's going on with Windows, you should go and get the sysinternals tools and get used to using them. However, I'm going to talk about Linux. I was just being fair there and letting people know that Windows stuff does exist. So Linux has something that's pretty interesting. It has something called private dirty pages. And a private dirty page is exactly what we want. It's private, which means that only our process has this memory map to it. It's dirty, which means it's being used. So this is perfect. This is exactly what we're after. We're after the stuff that is unique to us. And you get that information by doing a cat of procpid SMAPs. So every process running on your system has these SMAPs, or segment maps, that give the details of memory utilization that's mapped into that process. And you can just grep for private dirty and find out how much memory is being used in that particular PID. And there'll be several SMAPs for each process, or there can be. If you're running a big system, unfortunately, this takes a lot of time. So, for instance, I ran this on a system with about 2,000 progress processes running on it. It took about 5 minutes. So it's not something you just do casually. But you can do it. There's a tool that you can get from this website, selenic.com, called smem. It's a little Python script which will do all that work for you. You can either do an apt-get install or download it the hard way and install it that way. But it's just a little script that puts this stuff together, and can make some nice pretty graphs for you. Or give you a report kind of like PS. And this USS here, this is like the virtual size that you see in top, or the working set size. And this is the unique set size, which is the number that we're looking at. PSS is the proportional set size, and that's kind of a guess at what proportionally your memory use is if you take the shared stuff and you divide it across everybody. That's not really as useful. This is generally much more relevant. Or I wrote a little program called PrivateDirtyP, which we ship with ProTop. You can try it out. It's a little 4GL program that does all the dirty work for you. And surprisingly, it is not any slower than the C code that does the same thing. So the time that it takes to get this data is really being controlled by the operating system populating those SMAP tables rather than the execution speed of the 4GL. And this is really great because it gives you a good report of memory usage sorted by who the big pigs are, and gives you some additional information like when the process was started, how old it is, how much CPU time it's been accumulated. This particular screenshot, I know it's a little hard to read, but what you see here is that there is a program at the top called LSA start. That's a disk driver, and that's a buffer for the file system. It's doing some sort of buffering of a RAID array. And then somebody, for reasons that are a mystery to me, started X Windows in GNOME on a database server, so that's using all kinds of memory that didn't need to be used. But after that, it gets a little more reasonable. You can see that there are a bunch of app server processes here. And, and interestingly, there's a kind of a trend that the longer the app server has been running, the more memory it's using. I wonder what that could be. That sounds kind of like maybe a memory leak. Now, it was actually much worse the first time I ran this. We've been cleaning up the memory leaks over time, and this is getting so it's not too bad. But it was quite a rapid memory leak at first. We nailed a couple of things here. Here's a couple more still need to be done. Yes? Where's the database? Well, interestingly enough, the database is not a significant contributor to the well, there's an mproserve up here, but relatively speaking, it doesn't have that much memory that is private to its process. It has a lot of shared memory. This guy's using 100 gig for their dash B, but that's not showing up here because that's not private. That's shared with everybody. Another thing that you can do using either that or the smem data is you can take your progress clients and run them with different parameters. So one of the things I did I thought would be kind of fun was to see what the actual impact of using different startup parameters on a client session is. So here's the client sessions and the different parameters I used. You see that most of the parameters are really just setting a limit. They're not pre-allocating the memory at startup because the total size there is not that different. The big exception is BT, so your temporary table buffers. Those get allocated right away at startup, much like the big B does for the database server, except this isn't shared, so it's private to your session. And that's really important to know, because if you're setting your BT value to a very large value, and you have a lot of app servers or shared memory types of connections on that server, you can use an enormous amount of memory very, very quickly. We had a client a couple of years ago who set their BT to, I forget exactly what it was, but it was a 6-digit number, I think. And they pretty much swamped the database server, and they were having a hard time figuring out what they had done that had over-allocated memory on that server until we started looking at the clients and say, oh my goodness, those clients, that's huge. Well, we need that for some process or other that one or two of them ran. So how about if you have a different PF file for that process and have your regular people just use a normal BT, and these guys who need the really big one, they can have the really big one, but everybody doesn't need to have that. Solve that problem, things got much better. So anyway, this gives you an easy way of pulling together the data and confirming that what you had in the earlier slides about figuring out what your individual contributions of client data are. Another interesting thing here is you notice when you start up with a -P in a startup procedure versus just a -1, that you actually use less memory. Yeah, you're using 7.8 meg for the -1, and we're using 6.8 for the one that actually starts a procedure. That's because the procedure editor uses a bunch of memory. So, interesting thing to know, in case you were ever wondering about that. Yes, Bronco.
When you look at pass with multi-session agent, the -BT, is that actually going to the multi-session agent or the session behind beneath it?
So you're asking about with a PAS-OE, how is BT assigned? I think that's going to be one per thread because it's got to be private to the individual thread that's executing. I have not actually tested that, but that's what I would expect. Okay. Oh, yeah, just in time. That's time for questions. Do we have any other questions? Comments?
Nothing from the chat right now.
Nothing on the chat? Okay.
Here, that's something going to show up at the multi-session agent, because if you look at caching, for example, the -BT is used for caching reasons quite a lot.
Yeah.
But multiplied by the number of threads and you're going off to, and a lot of times it contains the same information for all the threads because they're using it as cache. So when they came up with the concept, I think, oh, well, the next logical thing would be to have something on the multi-session agent level as well, which you share with all the threads.
So you're suggesting that Progress should do an enhancement to share the temp table buffers somehow between multiple threads in somewhere? Well, that's an interesting idea. I'm not sure how development would react to that. We could see if we could, well, just maybe Peter would have an idea. Or, yeah. Sorry? On the app server? Yeah. Well, in order to share caches, you have to be able to say this one is shared and this one is private. And why wouldn't you use a database if you're doing that? I mean, that's basically what you're getting at that point is you have a database which is maybe it's read-only, although somebody's got to be able to write to it. So things get pretty complicated if you do that. On the other hand, now you mention that, the operating system does do a lot of interesting things that are very similar in that pages which are held in common are copies of each other, or there's really only one copy, and they don't become a second page until you write to it. So you have the copy on write feature that probably is doing a lot of that sharing and caching for you, or could to some degree in the mappings. Anything in the chat?
New.
Okay. Well, thank you very much.